Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Today we will discuss electric field due to linear charge distribution only. So uniformly distributed charge. Okay, so I'm just writing it.
We can do the linear charge distribution for non-uniform.
Non-uniform I will do it later. We
Yes,
have in uniform also we have more cases. So yesterday we solved electric field due to uniform charge distribution along a rod at a point on the axial line.
Yes, sir.
Today we are going to do at a point on the equatorial line. Okay.
Yes, sir.
So let's say this is my rod and uniform charge distribution. That means I am taking lambda as constant, right? Linear charge distribution, I will use lambda, and uniform means lambda is constant. Is this clear?
Yes, sir.
And what is lambda? Lambda is nothing but the total charge upon the total length of the rod.
Yes, sir.
So let us say this is a rod having a total charge capital Q on it, and the length of the rod is capital L. Okay.
Yes, sir.
Now we need to find the electric field at a point P, which is at a distance x from the midpoint of the rod.
Yes, sir.
Okay. So we need to find the electric field at a point P due to this uniform distribution, which is at a distance x from the midpoint of the rod, and this line is perpendicular to the rod. Clear?
Right, from every point the hypotenuse differs.
From every point the hypotenuse differs. Yes.
Yes, sir.
In yesterday's derivation also, from every point our distance was varying.
Yes, sir.
That's the reason we require calculus in this. Correct?
Yes, sir.
So we need to find, instead of x I'll take this as a, okay, because x I will use it as a variable. So electric field due to this rod at a distance of a from the midpoint, and this line is perpendicular to the rod.
Yes, sir.
Correct? And lambda is basically charge per unit length. So because it's a uniform rod, I can write it as total charge Q divided by the total length L. Clear?
Yes, sir.
Now how do I start? What I will do is I will draw another figure. Okay, so this is the question part of it. This is the given information and this is the question part of it, that we need to find the electric field at a point P. Okay?
Yes, sir.
Now I'll draw a new figure. So this is my rod, this is length L, this is the midpoint. Okay?
At the distance R we take
Correct.
The small element.
So that's the song. So first in the song, I need to choose a reference. So I will take the midpoint as the reference. Correct?
Yes, sir.
Then at a distance of r along the rod, I will take a small element dr,
Yes,
wherein the charge on this small element, I will take it as dq. Clear?
Yes, sir.
Implies I can say that the lambda for that small portion can be written as dq upon
dq by dx.
Yeah, so here we are taking r, so I've written it as r. Okay.
Yes, sir.
Now I will just connect these two with a dotted line. The electric field due to this small element over here will be in that direction.
Yes, sir.
And it is d. Is this clear?
Yes, sir.
Understood?
Yes, sir.
Here I want to explain a very important concept. Okay. So tell me, so I've taken the element, small element whose charge is dq, and I know that this distance is a, correct?
We get hypotenuse as a square plus r.
Root over a square plus r square
Yes,
will be the hypotenuse.
Yes, sir.
So I will find the electric field d due to this charge, correct?
Yes, sir.
And I'll integrate it.
Yes, sir.
Is this clear?
Yes, sir.
Is this correct? See, just now you said that is wrong actually. And that is a very important concept. This is a very important concept that I'm telling. Just now you said as the charge varies along the rod, as the element is moving along the rod, or we are shifting the element along the rod, the direction of the electric field is constantly varying. Correct?
Yes, sir.
And after finding d, what are we doing? We're integrating. Integration, in other words, in layman terms, is what? Addition. So when I'm doing integration of d, can I say that I'm doing addition of d? Correct?
Yes, sir.
Just now I said people forget that electric field is a vector.
Yes, sir.
When I am doing addition of d, that means I am doing addition of vectors, right?
Yes, sir.
Then actually I should be following the vector rules, vector laws.
Yes, sir.
Triangular law, parallelogram law.
Yes, sir.
I can't just do integral of d. Are you getting my point?
Yes, sir.
So I'll just write it over here. That usually we feel let's find d and integrate, but this is a wrong thing. Why it is a wrong thing? I'll tell you right now. The statement is you cannot integrate a vector whose direction is changing. You cannot integrate a vector whose direction is changing.
Yes, sir.
Why?
So we can't add all the directions.
Because integration is more or less scalar addition. And when the direction is varying, and when I'm calling it as a vector, direction is present, right? And when the direction is varying, I cannot do scalar addition.
We cannot get the exact direction.
It is not about cannot get the exact direction. I will give you an example to emphasize thoroughly on this. I will give you a proper example. Okay. I will dictate the statement also, and it's a very important concept. Therefore, we will put star marks. Okay. So when you're writing, after you write, I'll dictate that statement also. Okay. But right now, as a discussion part, understand this carefully. I said you cannot integrate a vector whose direction is changing. So do I mean that I can integrate a vector whose direction is not changing? See, why can't I integrate a vector whose direction is changing? Because I said integration is nothing but addition.
Yes, sir.
We cannot do scalar addition to a vector.
Then we consider only the scalar part and
If the direction is not changing, then can I do scalar addition?
yes, sir.
Obviously, right? Suppose I have a vector I cap. Suppose I have a vector.
Yesterday's example only.
Yeah, and another vector 2 I cap. I can
Hmm.
simply do 1 plus 2 and say that the addition of these two vectors is 3 I cap.
Yes, sir.
Correct?
Yes, sir.
But suppose one vector is I cap, other is j cap. I cannot say this is 2.
Yes, sir.
I plus j is not 2, and its magnitude is in fact root 2.
Yes, sir.
So clearly understand this statement. You cannot integrate, that means you cannot do a scalar addition of a vector whose direction is changing. But if direction is not changing, then I can do scalar addition. Is this clear?
Yes, sir.
But in our sequence, as the point charge is varying along this rod, my direction of D is constantly changing, correct?
Yes, sir.
100% I cannot do direct integration.
Yes, sir.
Is this clear?
Yes, sir.
Now, so how do I do it? So what I will do is, I will define little bit of geometry. Let this angle be theta.
Yes, sir.
That means this angle is also theta.
Yes, sir.
Now I can take components of these vectors. So this component will be what? D
D cos theta.
D cos theta. And this component will be,
D sin theta.
is this clear?
Yes, sir.
Now, by taking components, what did I do? I have fixed the direction of this D cos theta fellow.
Yes, sir.
And fixed the direction of D sin theta fellow.
Yes, sir.
Now I can individually integrate it.
Yes, sir.
Is this clear?
Yes, sir.
Now, so basically to get integral, I will do integral of dE cos theta, correct?
Yes, sir.
And then I will do integral of dE sin theta, right?
Yes, sir.
So in this direction also, I will get the magnitude of what the electric field is, net electric field is, and in that direction also, I will get the magnitude of net electric field, correct?
Yes, sir.
So no problem, we can do it like this, but we can still simplify this particular situation. Okay, how can I simplify this situation? Is it clear till here?
Yes, sir.
Geometry. Okay, how to simplify this particular situation is simply geometry. What will I do? Here I have taken an element dq. Now symmetrically over here also at a distance of r, I will take a small element of length dr. Is this clear?
Yes, sir.
And this dr element will also
dq.
have a charge dq.
Yes, sir.
Is it clear?
Yes, sir.
Now, the electric field due to this element at that point will be in this direction.
Yes, sir.
What will be the magnitude of it? Magnitude is d, right?
Yes, sir.
And what is this angle? Same as
Then it will be theta.
because
So
of
the
symmetry.
components are sin theta.
Perfect. So basically here I'll get a component dE sin theta, and basically dE sin theta will cancel each other. And here I will get another dE cos theta,
D cos theta.
2dE cos theta. That means I don't have to do integration twice. Because of symmetry of the rod, I can do integration only once and get the answer. Is this clear?
Yes, sir.
Understood?
Yes, sir.
Take a look. So basically, for this particular question, okay, where this point which is there, we are mentioning this point as midpoint, right?
Yes, sir.
And the charge is uniformly distributed. That means the lambda is constant. For this particular case, my components of dA sin theta will cancel due to the symmetrical elements, and simply to get the net electric field magnitude, I just have to do integral of 2 dE
Cos
cos.
theta.
Is this clear?
Yes, sir.
Understood?
Yes, sir.
Now, let us move ahead and find out what this dE is. What is dE? dE is electric field due to a charge dq, right?
K dq by
K dq upon
A
this.
square plus R
Correct.
square.
So this distance we said it is a square under root of a square plus r square, right?
Yes, sir.
That means in the denominator I will get what? A square plus
Square plus R square.
r square. Fine.
Yes, sir.
One more thing I want over here, that is cos theta. Right? So what is cos theta in the geometry? Cos theta is adjacent.
Okay. Yes, sir.
Adjacent upon hypotenuse.
A by under root of.
So I'll draw the triangle over here. So this angle is our theta. This is A, and the hypotenuse is under root of a square plus r square. Correct?
Yes, sir.
And this is r. So cos theta I will get it as a by under root of a square plus r square. Is this clear?
Yes, sir.
So let me come to the final solving of this. So I'll take 2 as constant. I'll bring it out. Right?
Yes, sir. Yes, sir.
I'll just substitute first. A dq upon I have a square plus r square. Correct?
Yes, sir.
Into what is cos theta? Cos theta
A
is
by under root of A square.
fine.
Yes, sir.
From this particular situation, I know dq is lambda into dr. So I'll substitute that. So 2 integral of a lambda dr into a divided by, if I'll combine these two,
A square plus R square power 3.
3 by 2. Clear?
Yes, sir.
Now basically this k is a constant. Lambda is also a constant. Right?
Yes, sir.
And a is also a constant.
Yes, sir.
So basically I'll get all the constants outside. 2k lambda a. Fine?
Yes,
Integral
sir.
of dr upon a square plus r square whole to the power 3 by 2. Is this clear?
Yes, sir.
Now how should I solve this?
We take A square plus R square as some.
We need to integrate this using some substitution, right?
Yes, sir.
Okay. I have to do
Yes, sir.
something. One of the things that we've learned in integration is by substitution, because there is no direct formula known for us.
Yes, sir.
So what will I substitute? I will tell you, in most of our physics chapter, we don't usually substitute something out of thin air. What we have to substitute is just to go back to the geometry.
Does part 1, yes, sir.
See, once we reach here, after doing everything, which I'll explain again right from the beginning, okay? After doing everything, after coming over here, I don't need to do any PhD. Why? Most of the physics derivations are based on the geometry. So first your attention should go to, will geometry give me a answer to this? Okay?
Yes, sir.
So if in this geometry, if I take a look, tan theta is what? Opposite by adjacent, correct?
Yes, sir.
That means I can get R is equal to A tan theta.
Yes, sir.
More or less, I am doing some kind of a substitution only. I'm transforming r in terms of theta.
Yes, sir.
As r varies, theta is also varying.
Yes, sir.
Is this clear?
Yes, sir.
So now, whenever we substitute, we should.
We differentiate.
So differential of this dr is equal to what will I get?
Secant
A
square theta
secant square theta.
into d theta.
Good. Mostly the reason why I say in calculus, whenever you differentiate, you will get a differential element. Is basically here if we forget, then again we'll get confused.
Yes, sir.
Is this clear?
Yes, sir.
Let us substitute and see. So my integration will become 2k. By the way, what is lambda?
dq by d.
Capital Q upon L.
Oh, yes, sir. Yes.
Okay. Times A integral of what is dr? A.
A secant square theta d theta.
Correct? Upon.
Yes, sir.
In the denominator, I have a square plus what is r square?
A tan theta.
So I'll have a square tan square theta whole to the power 3 by 2.
Yes, sir.
A square is common.
We bring it. Yes, sir.
It will become a cube. Correct? When I'll get it out, it will become a cube.
Yes, sir.
Numerator, I have a square already. A square by a cube will be a in the denominator. Correct?
Yes, sir. Yes, sir.
So here it will become
We can
2k.
take that out because it's constant. Everything is constant.
Okay, I'll get a in the denominator, right?
Yes, sir.
We can take that r. What did you say? We can take
So I was telling that we can take it. I mean, now everything turned into constant.
No, we have theta is a variable.
Yes, sir. When we integrate, it will. Okay.
We'll come to that.
Yes, sir.
Okay. First, let us do the integration, and then we'll eventually come to that. Okay.
Yes, sir.
So my a square, when I take it out, here I have what? 1 plus tan square theta,
Yes, sir.
which is secant square theta,
Yes, sir.
will become secant cube theta.
Secant cube theta.
Secant square theta by secant cube theta
Yes, sir.
is cos
Secant.
theta.
Yes, sir.
1 by secant theta, which is cos
Yes,
theta.
sir.
So this became a very easy integration. Is this clear?
Yes, sir.
So basically my ultimate integral answer will be 2kq. Integral of cos theta is what?
Minus, no, sin theta.
A into L sin theta. Of course, I am not right now mentioning the limits. I will mention the limits. But first, let us take a look at the entire thing again. Okay.
Yes, sir.
See, so question begins like this. A rod of length L has uniform charge distribution of total charge capital Q along it. Find the electric field at a distance of A perpendicular to the rod due to the rod.
Yes, sir.
Find the electric field at a point P, which is at a distance A. Correct?
Yes, sir.
I said, obviously, because there is charge distribution, we will take song. Here comes the song, right? Taking midpoint as the reference, I will start
Yes,
the
sir.
song by saying, at a distance of r, I will take a small element dr having a charge dq, and the electric field due to this dq charge at the point P will be P in that direction. Correct?
Yes, sir.
Then I will feel that integral of dE will give me the answer. But I have to understand that integral dE will not give me the answer, because here, as the charge is varying along the rod, yeah, tell me.
And direction is varying.
The direction is varying. So we just now realize that I cannot integrate a vector whose direction is changing. Clear?
Yes, sir. Yes,
Then
sir.
we came to a point, can I integrate a vector whose direction is constant? Yes, I plus 2i is 3i. Scalar addition, right?
Yes, sir.
So therefore, to fix the directions, I have taken the components of this vector, dE cos theta and dE sin theta. Is this clear?
Yes, sir. Yes,
You
sir.
can take this angle as theta, that angle is theta. That is your choice. The only thing that you need to remember is take the components.
Yes, sir.
I am taking the component in this directions actually because, see, once we take the components dE cos theta, dE sin theta, when I integrate both of them, I will anyways get the answer. Correct?
Yes, sir.
But why am I taking the components along this line and this line is, if I use the symmetry part of it and choose a small element dq on the other side of the midpoint, right? The distance of r, take a small element dr having a charge dq. Same story, the electric field due to that will be d in that direction, correct?
Yes, sir.
And due to symmetry, the component in this direction is dE sin theta, component in that direction dE cos theta, which will cancel my dE sin theta, and therefore the entire resultant due to symmetry will be 2 dE cos theta in the vertical direction. Is this clear?
Yes, sir.
Next, coming to the calculus part of it. So I said, so the net electric field, we know the direction will be in the upward direction, is nothing but integral of 2 dE cos theta, correct?
Yes, sir.
I have to know what dE is and I have to know what cos theta.
Yes, sir.
dE is k into charge is dq. So k dq a square plus r square. Correct?
Yes, sir.
And what is cos theta? According to the triangle, cos theta is adjacent upon hypotenuse.
Yes, sir.
So I know dE, I know cos theta. Just substitute over here. Doing some stories and all, substituting dq and rewriting it here and there, I have come to this situation.
Yes, sir.
Now I have come to integration part of it, mathematics, calculus.
Yes, sir.
There, here I told you, very important thing again is what? Instead of trying to do some kind of substitution and trying to do some kind of a, PhD kind of a science in it or mathematics in it, rather it is usually in physics especially, usually go to the geometry, it will give the answer. So my geometry gave the answer as what? Tan theta is r by a, correct?
Yes, sir.
So that means I can cross multiply, write r is equal to a tan theta, and this itself will behave as a substitution.
Yes, sir.
Once that is there, once that is established, whenever I substitute, I will differentiate. Therefore, dr I will get it as a secant square theta d theta.
Yes, sir.
Put everything over there. All the constants are outside.
Hmm.
Inside, what do I have? In place of dr, a secant square theta d theta.
Yes, sir.
And in the denominator, I have a square plus a square tan square theta whole to the power 3 by 2.
Yes, sir.
Which eventually will become a cube. And the 1 plus tan square theta will become secant cube.
Yes, sir.
So secant square by secant cube will give me cos theta.
Cos theta.
Integral of cos theta is very easy. Sin theta. Is this clear?
Yes, sir.
Take down till here. I'll come to the limits part after you write it down. Okay?
Yes, sir.
Xerox. Is this clear?
Yes, sir.
So I'll just explain this once again. What we are saying here is that while substituting r is equal to a tan theta, I already know the limits of R, which is 0 to L by 2, correct? So when R is 0, I want to know what is the value of theta 1. So I'll substitute 0 over here. So tan theta 1 will also become 0. This is the first limit. And when R is L by 2, my tan theta 2 will become L by 2a.
Yes, sir.
When I substitute L by 2 over here in place of R, tan theta 2 will become L by 2a. So my limits I am substituting from theta 1 to theta 2, correct?
Yes, sir.
And when I am substituting from theta 1 to theta 2, my theta 1 entire thing is going to become 0.
Yes,
Right?
sir.
This entire thing will become 0 because tan theta 1 is 0. And tan theta 2 I will substitute. So I will get L by 2a divided by under root of 1 plus L by 2a whole square. Is this clear?
Yes, sir.
Now,
Is it whole square?
yeah, is it clear?
That part is becoming 0 now, sir.
The second part is becoming 0.
So why is it 1 plus L by 2a?
First part has 1 plus L by 2a whole square.
Yes, sir. Yes, sir.
Right? Forget this part. Here I
Yes,
have
sir.
under root 1 plus tan square theta 2. So 1
Yes.
plus L by 2a whole square is there in the denominator, the root.
Yes, sir.
Here.
Yes, sir.
Now, the second method, okay, I'll just erase this example. So the second method, let me write it as method 2 over here. I got the integration as sine theta.
Yes, sir.
Now in my triangle, if I will look at the previous triangle, I had this is R, this is A, and this is theta, right?
Yes, sir.
And the hypotenuse is under root of A square plus R square, correct?
Yes, sir.
So instead of going in terms of tan theta and following the substitution, here only I will bring theta in terms of R.
Yes, sir.
So what should I write? I will write 2kq by AL. What is sine theta from the diagram? Opposite by
R by under root.
R by under root of A square plus R square, correct?
Yes, sir.
And what is the limits of R? Just now we said from 0 to L by 2.
Yes, sir.
Because the mirror image is already counting. We have already taken 2 elements.
Because we have the, I mean, 2D cos theta.
2D cos theta. Because we have already considered the effect of these 2 elements while we were solving the before solving the integration. Now I don't have to vary R from minus L by 2 to plus L by 2. I can vary R from 0 to L by 2, and its mirror image is already taking it from 0 to minus L by 2 automatically.
Sir, is it like you showed an example like those two people are eating apples? So if 4 apples are being completed, but I mean,
So
we
I
are
told,
considering only 2%.
so who is my variable there? Ramu is my variable there.
Yes, sir.
I will tell Ramu eat 4 apples. So Ramu ate 4 apples.
But we are getting 16. I sorry, 8.
How many apples are consumed? 8 apples are consumed. Because I have taken a mirror image of Ramu over here, put Shamu over there and said, you eat the apple whenever that fellow eats apple. So when the element is here, this element is also here, and we are considering the effect of both, right?
Yes, sir.
So as the right element is varying, my left element is also symmetrically varying.
Yes, sir. Because we fixed the resultant.
Is this clear?
Yes, sir.
Understood?
Yes, sir.
Because we have considered the effect of this variable already in our components.
Yes, sir.
Already considered the effect of my symmetric variable in my components. And
Yes,
like you
sir.
said just now, because it is coming to 2d cos theta, that means I just have to vary this fellow, automatically that element is also varying.
Yes, sir.
Is this clear?
Yes, sir.
So my lower limit is 0, upper limit is L by 2. Now I'll do upper limit minus lower limit, correct?
Yes, sir.
Lower limit anyways is 0. I don't have to write it. So my upper limit only I have to substitute.
Now R is varying, so we put it on.
R is varying from 0 to L by 2. Okay.
Wouldn't it be minus? No. Yes, sir.
Is this clear?
Yes, sir.
The net electric field, I will get the answer as this. I can further cancel off L here and here. 2 will also get cancelled. Correct?
Yes, sir.
My final answer basically will become KQ by. I have an L outside. No, L also got cancelled, right? I have a outside.
Yes, sir.
I have a outside. And here I have a square plus L by 2 whole square whole to the power 1 by 2. This is my final answer. Clear?
Yes, sir.
So that is the technical way of mathematics. Usually in physics, we can do this also. If you see, this is very short, right? But when we are discussing in mathematics, what is my value of theta? Sometimes it might become important. So usually in mathematics, we do it that. Understood?
Yes, sir.
If you solve, eventually this fellow will also become the same thing. The entire thing will become the same. Take it down. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.